Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting presentation on the DTC P006E error code, identified as a turbocharger power supply circuit malfunction specifically for the Honda CR-V 2023 and later models. This error code indicates that the power supply voltage for the turbocharger wastegate control actuator has fallen below a predetermined threshold, causing the powertrain control module, PCM, to register an abnormality. The malfunctioning component is located within the turbocharger assembly, where the wastegate control actuator is positioned. This actuator plays a critical role by regulating the turbocharger boost pressure, which enhances engine efficiency and performance. In the event of a voltage supply issue, drivers may experience reduced engine performance, and the PCM will store this DTC to aid in diagnostics. The importance of addressing this problem cannot be understated, as it could lead to more significant issues within the engine management system. The DTC P006E pertains specifically to the turbocharger wastegate control actuator, a vital component that helps control the turbocharger's boost pressures. When this actuator experiences a voltage drop in its power supply circuit, it indicates a malfunction that the PCM detects. The PCM, or Powertrain Control Module, is responsible for interpreting signals and managing engine functions, making it essential for the efficient operation of the vehicle. In the case of the Honda CR-V 2023 Plus, the affected circuit could be causing inadequate boost pressure, leading to suboptimal engine performance. Located within the turbocharger assembly, the wastegate control actuator's position makes it crucial for maintaining the correct pressure levels. Therefore, understanding this component and its electrical supply is essential for proper diagnosis and repair. There are multiple potential causes for the DTC P006E error code. The first possible cause is an open wire within the power supply circuit that connects to the turbocharger wastegate control actuator. An open circuit due to fraying or damage could result in insufficient voltage reaching the actuator, thus triggering the error code. The second possibility involves a shorted wire within the same socket. This could occur if the wiring comes into contact with a grounding point, leading to an excessive voltage drop. Lastly, if both the wiring inspections return normal results, a faulty powertrain control module, PCM, could be the cause of the issue. This module is responsible for managing electronic signals in the vehicle, and if it fails, it may not provide the necessary commands to the wastegate actuator. When dealing with DTC P006E, several symptoms can manifest. One of the most obvious is a reduction in engine performance. Drivers may notice a significant lag during acceleration or a failure to reach optimal speeds. This is primarily due to the malfunctioning turbocharger wastegate control actuator, failing to regulate the necessary boost pressure. Additionally, the check engine light will likely illuminate on the dashboard, alerting the driver to the presence of a fault code. In some cases, there could also be symptoms of turbo lag, where the engine takes longer than usual to respond when the accelerator is pressed. Recognizing these symptoms early can prevent further damage to the vehicle's engine and its associated components. The first step in troubleshooting DTC P006E is to prepare the vehicle for inspection by turning it to the on mode. This action powers up the vehicle's electrical systems, allowing for proper diagnostics to be conducted. Inspect all electrical connections related to the turbocharger wastegate control actuator and the PGM-FI subrelay for any visible signs of damage or corrosion. These factors can impede proper circuit function and contribute to the DTC being triggered. It is vital to ensure that all connections are secure and free from debris. Often, a poor connection can lead to intermittent faults that are difficult to diagnose. After visually inspecting these components, the technician should proceed to perform wire inspections. In this step, the focus shifts to inspecting the power supply circuit for open wires. Before disconnecting the PCM connector, the technician should jump the SCS line using the HDS and wait for over a minute. Disconnect both the PGM-FI subrelay and the PCM connectors to perform an open wire inspection effectively. The procedure requires measuring the resistance across the VBACT-FI subrelay out, while ensuring that the ignition IG mode is in the off position. A normal condition reveals a reading of less than 1 ohm, indicating that the circuit is intact. If the resistance measured exceeds this value, it signals an open circuit condition that must be further investigated. Identifying these issues is crucial for avoiding unnecessary component replacements later in the troubleshooting process. The third step involves checking for shorted wires in the circuit. As in the previous step, ensure the PCM and PGM-FI subrelay remain disconnected. The technician will measure the resistance between VBACT, FI subrelay out, and ground while the circuit is still open. The ignition should be off to obtain accurate readings. Here, a normal condition should show resistance greater than 1 mega ohm. If the resistance is lower, it indicates that there may be a short to ground somewhere in the circuit, which can disrupt the voltage supply to the turbocharger wastegate control actuator. This shorting can lead to undesired electronic signals and ultimately cause the PCM to flag the DTC P006E. It's essential to address these findings immediately to restore the circuit's functionality. In this final troubleshooting step, the emphasis is on performing a thorough inspection of the powertrain control module, PCM. If both the open and shorted wire inspections came back normal, this points to the PCM as a potential source of the malfunction. A functioning PCM is critical because it orchestrates multiple engine functions, including the operations of the wastegate actuator. During the inspection, technicians should check for any fault codes that may indicate further issues within the PCM itself. Utilizing the HDS and accessing advanced diagnostics will help in determining if the PCM is operating optimally. Any faults found within the PCM will require examination and possibly replacement, which is a significant repair due to the PCM's integral role in vehicle performance. After successfully completing the necessary repairs associated with the DTC P006E, a final repair verification step is essential. Technicians must confirm that all repairs made to the circuit, subrelay, and possibly the PCM have been executed correctly. Following this, reset the DTC stored in the PCM using the HDS or diagnostic tool. This resets the system and clears the code that was stored due to the previous malfunction. To ensure that the issue has been fully resolved, a test drive of the vehicle should follow. During the test drive, monitor the vehicle's performance and check that the check engine light remains off. Successful completion of this verification indicates that the DTC P006E has been addressed effectively and the vehicle is functioning correctly. To help prevent future occurrences of DTC P006E, it's advisable to practice regular preventive maintenance on the turbocharger system. Schedule routine inspections of the turbocharger's electrical circuits and ensure that all connectors are intact and free from corrosion. Even minor issues, such as loose connections, can lead to significant problems down the road. So proactive management is essential. In addition, monitoring the turbocharger's performance regularly can aid in identifying any early indicators of malfunction, allowing for timely repairs. Keeping an eye on engine performance characteristics can also reveal potential issues before they escalate into more significant failures. By implementing these preventive measures, vehicle reliability can be enhanced, ultimately improving engine performance. In conclusion, Understanding DTC P006E as a turbocharger power supply circuit malfunction is crucial for any Honda CR-V 2023 Plus owner or technician. Identifying the symptoms, including reduced engine performance and the check engine light, allows for early intervention. Potential causes like open or shorted wires and PCM issues must be systematically investigated to find the root of the problem. Following a thorough troubleshooting process ensures that all aspects of the turbocharger control circuit are examined, leading to effective repairs. Implementing preventive maintenance will further enhance vehicle reliability and vehicle performance. By taking these steps, drivers can ensure their Honda CR-V remains efficient and responsive, ultimately leading to a better driving experience. Please like and subscribe to the channel. See you next time.